In today's lecture, we shall discuss about the loop construct. Basically, we can find this loop construct inside procedural block, right? Inside either we can write this loop construct inside always block, or we can write it inside initial block. So this loop construct is just similar to the loop of high level language like C. So here we shall discuss about this in this lecture, while loop, for loop, repeat loop and forever loop. These four constructs we shall discuss. Now this while loop. The syntax for the while loop is while. So while is a keyword. Then inside the bracket we have to write the expression. So if the expression is true, then the sequential statement, whatever we write here, this sequential statement will execute. So sequential statement can be a single sequential statement, or it can be more than one sequential statements. So all the sequential statements which are written here will be executed till the expression gives true result. If the expression will give false result, then the loop will stop. So the value of expression is evaluated, and if it is true, then sequential statement executes. This sequential statement executes till the expression is true. The sequential statement can be a single statement or a group of statements within begin end. So already we know that if there are more than one sequential statements, then we have to enclose those sequential statements inside begin and loop. So here I have taken one example. Just I have declared one module, and the name of the module is XYZ, and then I have declared one variable of integer type, and name of the variable is my count. Then this is the initial block now, right? So whatever we write inside this initial keyword, all this will form the initial block. So we know that initial block is one of the procedural block. So we can write the loop construct inside initial or always block. Now here with this first statement, the my count value is initialized with 0. Then we have written the while loop, while my count less than equal to 5. So if the value of my count is less than or equal to 5, then the statement written inside while loop will be executed, and the statement which I have written inside the while loop is #5 my count is equal to my count plus 1. So whatever is the value of my count, 1 will be added in that, and the evaluated value will be assigned to my count. And this statement will be executed after every 5 unit time, because we have included the delay here 5, right? So this statement will run for that many number of times, for the number of times till my count is less than equal to 5. So I will just demonstrate this particular code in the software. So the code I have loaded here. So you can find the same code I have loaded here. Now I will check the syntax for this code. So behavioral check syntax completed successfully, so there is no syntax error. Now I will simulate this code. So this is the simulation result. So since the my count is an integer type, we already know that integer type in Verilog will be written in binary form by using 32 bits. So here you can find there are 32 bits, right? So initially we have now you can see this program. See, the value of my count is initialized with 0, right? So in while loop the my count value is 0. So 0 is less than equal to 5. This is true, right? So initially my count value will be 0. So you can find here initially at the start of the simulation at 0 ns. See this my count value. It is, you can read this value here. It is 32 bits and all the bits are 0. This indicates the value is 0, right? Right. Here also you can find it is 0. Now this statement, my count is equal to my count plus 1. This will make the my count value 1, and this evaluated value will be assigned to my count after 5 nanosecond, after 5 unit time. So here the simulation time is taken in nanoseconds. So after 5 nanosecond, this statement will be executed and my count value will become 1. So you can see in the simulation at 5, this is 5 nanosecond here. Now the value of my count is 1. So you see 32 bits, all the bits are 0, only the LSB is 1. So this indicates this is 1. Now again this condition will be evaluated. Now my count value is 1, which is still less than equal to 5. So again this statement will be executed. So again my count, which is now 1 will be added to this. So my count will become 2 and 2 will be assigned to my count. So my count new value is 2, but this will be assigned to my count after a delay of 5 unit time. So you can see here is 5 unit time. Up to this 5 unit time, the value of this my count is 1, but at 10 nanosecond you find the value of my count. It has become now, see the last two LSBs, it is 1 0. So this indicates it is 2 now. Now since the value of my count is 2, again this condition is evaluated. 2 is less than equal to 5. This is true. Again 1 will be added to my count. So my count will become 3 and 3 will be assigned to my count after 5 unit time. So you see after 5 unit time here, now at 15, you see now the value of my count has become last two digits, binary digits, you can see it is 1 1. 1 1 means it is 3. So at 15 unit time it is 3. Now again 3 will be means in while expression, this my count value is 3, which is still less than equal to 5. Again this is true. So my count, this statement is again executed and the my count value will become now 3, and this 3 will be assigned to my count after 5 unit time. So here you can see now at 20 unit time its value has become now now it will become 4. 3 was earlier, it was 3. Now at 20 ns it will become 4. So now you see here 4. Last 3 digits 101 in binary is 4. Right. Now is still 4 is in this program 4, this condition is evaluated, 4 is still less than equal to 5. So now 4 plus 1 will become 5, and 5 will be the new value of the my count after 5 unit time. So now it will become 5 at 25 unit time. So now you see in the last 3 digits 101 means 5. So still 5 is less than equal to 5, less than equal to 5. This condition is true. So again this statement will execute, and the my count value will become 6. So 6 will be assigned to my count after 5 unit time. So you see here now at 30 unit time the value of my count has become now last 3 digits, you see 110. 110 means it is 6. So it has become 6. Now now again this condition is evaluated. Now 6 is less than equal to 5. This is false now. Now since it is false, so this statement will not run, and value of my count will remain 6. So you see here my count value is remain 6 here. It is 6, right? Okay. So this is about the while loop. Now we will see for loop. Now in case of for loop, the syntax is for. Now within bracket there are 3 expressions: expression 1, expression 2, expression 3. Now expression 1 is for the initialization of the loop parameter, right? So with this we will initialize the loop parameter. Then expression 2 will be evaluated, and if this expression 2 is true, then the value of expression 3 will be means this expression 3 is a statement which can be used to update the value of the loop parameter, right? And if the expression 2 is true, then the sequential statement will run, right? So here the for loop executes as long as the expression 2 is true. So if the expression 2 is true, the sequential statement will run. The sequential statement can be a single statement or a group of statements within begin end. Already we know this. The for loop consists of 3 parts: an initial condition, expression 1. So this is the initial condition which is used to initialize the loop parameter. A check to see the terminating condition is true. So expression 2 is the check condition. So if expression 2 generates a true result, then the sequential statement will run. Otherwise it will stop. And a procedural assignment to change the value of the control variable. This is done by expression 3. So the value of control variable, that is loop parameter, can be changed by using expression 3. Okay, so the for loop is conveniently used to initialize an array of memory. So suppose this is a memory, right? Total locations are 0 to 1023. So total locations are 1024. So these memory locations can be initialized by using loop. Otherwise, for each location to initialize the location, initialization means to write value 0 or 1 in these locations, we have to write 1024 statements. So in place of that, you can use the loop to initialize all these memory locations. So this is one of the application of for loop. Now here the example is given. Module xyz integer my count. So here we have declared one variable of integer type, and name of the variable is my count. Then there is an initial block, then for loop for My count value is initialized here to 0. Then this is the expression 2, which is used to check the terminating condition of the loop. So if my count is less than equal to 2, then if this will give you the true result, then the loop will run. Means whatever statements written inside loop will run. And the expression third is my count is equal to my count plus 1. So this will change the value of my count. So this is expression 3. And here the statement is hash 5 my count is equal to my count. So whatever is the value of my count, it will be assigned to my count, and this statement is executed after a delay of 5 unit time. So here in this program, what we can see, initially the value of my count will be 0. So this is the value of my count and it is 0, right? Now since this 0 is less than equal to 2, this condition is true. Okay, this condition is true. So now what will happen? My count is equal to my count plus 1. This will change the value of my count, and my count will become 1, right? And this statement will be executed. So this 1, the new value of my count, will be assigned to my count, but after a delay of 5 unit time. So after a delay of 5 unit time, the value of my count will become 1. Now again this expression will be evaluated. Now still my count is less than equal to 2. Yes, true, it is less than equal to 2. Again my count expression, due to the expression 3, my count plus 1. So it will give a new value to the my count, and that will be 2, right? So now this 2, and now this statement is executed. This 2 will be assigned to 2 after 5 unit time. So here at this time, after 5 unit time, after gap of 5 unit time, and suppose if this is a 0 time, initial time of the simulation, so here at 10 unit time, the value of my count will become 2. Again this expression is evaluated. My count is less than equal to 2. Yes, still it is true. So if it is true, again my count plus 1, it will make my count, this my count equal to 3, and then this statement is executed, and now the 3 will be assigned to my count after a delay of 5 unit time. So after a delay of 5 unit time, means at 15 unit time, the value of my count will become 3. Then again this condition will be checked, my count less than equal to 2. Now it is false, and if it is false, then this statement will not execute. So here you will find up at 15 unit time, the value of my count will become 3, and then it will remain 3. So I will just demonstrate you this code also. I will just paste the code here. Okay, so now I will check the syntax first. Now there is no error in the syntax. Now I will simulate this code. Now simulation is done here, and this is the waveform. So now you can see, here we will see. Okay, so initially you can see the value of my count is 0. At 5 unit time it will become now 1. You can see LSB, it is 1. At 10 unit time it will become 2. Now see the LSB, it is 10. 10 means 2. At 15 unit time, you see here this 15 NS. 15 unit time it has become now 11. 11 means 3. right? And after this you will find there is no change. Anywhere you can click, you can find the value will remain same. So this is about the for loop. Now we will see the repeat repeat loop. Now in case of repeat loop, the syntax for the repeat loop is repeat within bracket expression and then sequential statement. So here the repeat executes the loop a fixed number of times. So this loop will run for a fixed number of times, right? The expression in the repeat, we are talking about this expression in the construct repeat construct can be constant, a variable or a signal value. So here you can mention a constant value, or you can mention some signal also. So whatever is the value of constant or whatever is the value of signal, for that many number of times this sequential statement will be executed. So if the expression is a variable or signal value, it is evaluated only when the loop starts and not during the execution of loop. So here the meaning is this: suppose here we have used some repeat loop, repeat, and here within bracket I have mentioned a. Let us assume a is an integer type and the value of this a, suppose we have assigned 3. So whatever statements written inside this loop, this will run for 3 times. Now let us assume this a is a part of some initial block, and when this repeat statement is executed, at that time whatever is the value of a at that time, that value will be considered here. But during the execution of these statements, if at any point of time the value of a changed, right, so that changed value will not be considered. Only at the time of the starting of the repeat, whatever is the value of a, that will be considered, because there may be possibility that we are using this a somewhere else in the program and that value is updated, that value has become 4 or 5, right? So but that value will not be considered. Only at the time of start of the repeat, whatever is the value of this variable, that will be considered, right? Okay. So these sequential statements can be a single statement or a group of statements within begin end. Already we know this. So this is one example. So repeat a begin end. So in begin end, if there are more than one sequential statement, then we will use begin end, and all the sequential statements will run for a number of times. There may be chances that variable a might be updated by some statement in initial or always block, but when repeat is executing, at that time whatever was the initial value of a will be considered. Same thing I explained here. At the start of the repetition, whatever is the value of a, that will be considered. Okay. So here we have taken one example. Module, name of the module is XYZ, and suppose the port of this module is CLK, one clock, and clock is an output port, and we have declared clock as reg type. Then there is an initial block, right? Then begin, and the statement CLK is equal to 1 tick B. So with this statement, what we are doing, at the start of the simulation, suppose this is T is equal to 0. At this time, this is CLK. this is time t is equal to 0. Simulation time is 0 and CLK. Value of CLK signal is at this time. It is 0 due to this statement. Then we have written repeat within bracket I have mentioned 2. This means this repeat 2 will execute the sequential statements written inside repeat for 2 times. And what is that statement? Hash 5 CLK is equal to not CLK. So here I have used the operator. So what this statement will do? It will complement the value of CLK. So CLK will become, earlier CLK was 0, now CLK will become 1. Right? Complement this and assign this value to CLK. So CLK will become 1. But this statement will execute after 5 unit time. Here we have mentioned this delay 5 unit time. So up to 5 unit time the value of CLK will remain 0. At 5 unit time, this is 5 unit time, the value of CLK will become 1. Right? So in this way this statement is executed one time now. Here it is executed one time. Now the CLK will remain 1 and again this statement will be executed. Now not clock will be assigned to clock. So right now the value of clock is 1. So the not for that is 0. So now 0 will be assigned to clock. But after 5 unit time. So again after 5 unit time, after the gap of 5 unit time, the value of CLK will become 0. So this will the second time repetition. This will become second time repetition. So at 10 unit time the value of CLK will become 0. So now 2 times this statement is executed, now it will not execute. So now the value of CLK will remain 0. Okay. So we can, so I will just demonstrate you this program. So here this is a program. First I will check the syntax. So there is no error in the syntax. So now I will run the simulation. So here you can find this simulation result. I will show you this. Now you see here, initially the value of this program, initially the value of CLK is 0, and when the first time this statement executes, then the value of CLK will become 1 at 5 unit time. So you see here at 5 unit time. So this is 5 nanosecond. At this time the value of CLK will become 1. Right? Will become 1. Now when this statement executes second time, so again the value of CLK will become 0. So that will become 0 at 10 unit time. So you see here at 10 unit time, the value of CLK will become 0 here. Now it is 0. Right? So now it will remain 0. You can see now it will remain 0 during the whole simulation period. So in this way, we can generate the clocks, right, of some limited number of times, right? So suppose in some application I want to generate this type of clock, and I want that this type of clock should be there for 100 times only, 100 times. So for this particular application, I can use this repeat. Proper value I can use in this parameter, repeat parameter. Then that many number of times I will execute this statement in order to generate this clock for 100 times. Right? Now another type of loop construct is forever loop. So the syntax of forever loop is forever. So forever is again a keyword. Then sequential statement. So here this sequential statement will run forever. Means for the whole duration of the simulation, this statement will run. So the forever construct does not use any expression and execute forever until $finish. So if you use this statement in test bench, so until this $finish, this statement is encountered in the test bench, this sequential statement will run up to that time. So $finish will stop the simulation time. So at that time, this statement will stop, right? Now the forever is equivalent to while loop for which the expression is always true. So now here you can see, here I have written one while loop. While expression is 1 less than 2, then the set of statements. So here this expression 1 is less than 2 will always true, and if it is always true, then the statements written here inside begin and end will continuously run for indefinite period. So this is also, so forever loop is also doing the same thing. Now you see the forever whatever statements you have written here, these statements will run forever till the simulation will run. So the while loop in which this expression condition is always true, it is just equivalent to the forever loop. Now this example is here, just to I will demonstrate this example. Now here you can see rig type clock is declared, initial keyword, then begin, and CLK is initialized as 0, then forever. So means this program, in this program what I have done, exactly same program, in place of repeat I am using here forever, right? So now what will happen due to this? This program will run till the simulation is running, right? Till the simulation is running, this program will run. So I will show you this program. So here what I do, I will remove this repeat and I will use forever. Right, now again I will check the syntax. It is true, there is no error. Now I will run the simulation. So now you will find for the whole duration of the simulation, this statement will run and you will find a clock signal. Continuously it is there. So now you see this simulation. Here you can find out this simulation run for 1 microsecond. Right, here the simulation period is given, it is 1 microsecond. So 1 microsecond means 1000 picosecond. So here up to 1000 picosecond this simulation run. Now this is a waveform, you can see here. This waveform is generated up to the end of the simulation, from the starting of the simulation. Starting of the simulation is, see here, and this 0 ns. From 0 ns to 1000 nanosecond, that is 1 microsecond. Simulation time is this duration. So for whole duration that statement is running due to forever loop, and continuously we are getting these type of signals, this type of clock. So see here, after every 5, this is 5 nanosecond. After every 5 nanosecond, there is change in the value of clock. So here at 10 ns, here at 15 ns, 20 ns, right? So this delay of 5 ns, 10 ns, 20 ns is coming due to this hash 5. We have included this hash 5. That's why that 5 ns delay is coming. Okay, so in this way we can use these type of construct of the loop in different applications.